The math really isn't mathing for me based on the sources.
Okay, what do you mean?
Well, if Google just told Meta they have no room, right? And compute is so scarce that they are getting capped and throttled, how does Meta concurrently launch a platform called Meta Compute to rent out their own excess GPU capacity to third parties? Like, are they desperately short on compute, or do they have so much they can run a rental service? Are they...
It's actually a massive buy and lease arbitrage strategy, and it's totally driven by the speed of the physical world.
Okay, walk me through that.
So the first layer to untangle here is the reality of the power grid. You can't just order a massive data center on Amazon Prime, right?
Right.
Meta recognized the compute shortage and signed a massive 1.6 gigawatt data center contract with a developer called Crusoe, spread across sites in Texas and Missouri.
And just to jump in and visualize that scale for a second, 1.6 gigawatts, that is enough electricity to power well over 1 million homes.
It's staggering.
They effectively bought a major city's worth of power solely to run AI models.
Yes. But having the power contract doesn't mean you have the plug ready to go today.
Because you have to build it.
Exactly. Electric grid connection queues take years. You have to wait for transformer supply chain backlogs to clear. You have to build substations. You have to navigate regional power scarcity. So that 1.6 gigawatts, that is long-term CapEx, capital expenditure.
Okay.
It's future-proofing for the multi-year AI agent pipeline they want to run 3 years from now. But it doesn't solve the fact that Google just throttled them today.
Oh, okay. So to survive the multi-year wait for the concrete to dry in Texas, they have to find compute somewhere else immediately.
Right.
So they went out and locked in massive bridging capacity leases. The sources say $27 billion with Nebius and $21 billion with CoreWeave. So they are spending tens of billions just to rent compute while they build their own power plants.
Yes, which brings us to the second layer of the paradox. Why are they renting out capacity through Meta Compute while simultaneously spending billions to lease capacity from others?
Yeah.
The answer is hardware life cycles. Computer hardware ages incredibly fast. Meta has a massive stockpile of older Hopper generation GPUs.
The H100s and H200s, right?
Exactly. And for cutting-edge frontier AI research, these chips are starting to lose their edge to the next generation, like NVIDIA's Blackwell series. But financially, these older chips are entering the middle to late stages of their financial depreciation cycle.
Meaning, from an accounting perspective, they've basically already paid for themselves. Their paper cost is practically zero.
Precisely. So Meta packages these older, fully depreciated GPUs and rents them out to mid-market developers who don't need the absolute bleeding edge.
Oh, wow.
And the rental income they generate is almost pure gross margin. It prints high-margin operating cash flow, which Meta then uses to offset the massive billions they are spending on those new Texas power plants and the CoreWeave leases.
That's so smart.
Yeah, while keeping every single brand-new cutting-edge Blackwell chip strictly locked inside Meta's walls for their own internal R&D.
So they're basically running a used car lot to fund the construction of a spaceship.
That is exactly what they're doing.
But wait, that still leaves one huge quotient. How did they free up enough capacity to rent out in the first place? If they were just getting throttled by Google, their internal capacity should be stretched to the absolute breaking point. Like they shouldn't have spare chips lying around to rent to anybody.
Right, and this is where the physical hardware narrative collides with a massive leap in software engineering. The industry calls it hardware-software co-design.
Hardware-software co-design.
Yeah, you don't just build bigger servers. You rewrite the software so it requires drastically fewer servers to do the exact same job.
Okay. And the sources detail this massive structural reorg. Mark Zuckerberg ran inside Meta in June of 2025 to tackle exactly this.
Yeah.
He formed the Meta Superintelligence Labs, or MSL.
Right.
He brought in Alexander Wang from Scale AI as the chief AI officer, and they dropped $14 billion to rebuild their entire AI stack from the ground up.
A total overhaul.
Yeah, and the result of that dropped on April 8th, 2026. MuSpark.
Spark, yeah.
It's a natively multimodal proprietary reasoning model.
Right.
And it's a huge departure from how Meta used to do things because it breaks from their open weights llama lineage.
Right.
And for context, open weights essentially means the underlying recipe of the AI was public, right? Anyone could download it. But MuSpark is entirely proprietary. The recipe is locked in a vault.
Locked away. And the defining feature of MuSpark, and this is the key to unlocking all that idle hardware you were asking about, is a mechanism they call contemplating mode.
Contemplating mode.
Yeah, it relies on a technique called thought compression, which happens during the model's reinforcement learning phase.
Okay, break that down for me.
Well, reinforcement learning is basically how you train an AI using trial and error.
Okay.
You reward it when it gets things right, and you penalize it when it gets things wrong.
Sure.
Typically, complex reasoning models are given a lot of leeway to generate these long, rambling chains of thought to arrive at an answer.
Okay, it's like hiring a highly paid consultant, right?
Yeah.
Traditional AI models are like that consultant who writes a 10-page jargon-filled essay just to answer a simple yes or no question and then bills you by the word.
Yes, exactly.
So what did Meta do? During training, the engineers actively penalized MuSpark for using excessive reasoning tokens.
They did.
They essentially put the AI through a brutal boot camp that forced it to find highly condensed multi-step paths to the correct answer. It trained the consultant to give you the exact same brilliant answer in one sentence, saving you an absolute fortune in processing power.
That's spot on. By requiring drastically fewer floating point operations, which is the raw mathematical horsepower needed for every query, MuSpark effectively multiplies the capacity of Meta's existing physical hardware.
Wow.
That leap in software efficiency is what freed up so much of their internal hardware capacity. They didn't go out and buy more old chips. They just made their software so efficient that they didn't need a huge chunk of the chips they already had. And that is the inventory they are renting out.
That is wild. And MuSpark isn't just like a slightly more efficient chatbot. The benchmark numbers from the sources are staggering. When they put it through humanity's last exam, which is this brutal industry benchmark for advanced scientific reasoning, it didn't just edge out the competition. It broke the 50% barrier, scoring up to 58.0%.
Which was unheard of at the time.
Yeah, because OpenAI's GPT 5.4 was at 43.9%, and Google's Gemini 3.1 Pro DeepThink was at 48.4%, and MuSpark hit 58.
Yeah.
It did the same thing on HealthBench Hard, scoring 42.8%, completely dominating in clinical and medical reasoning.
Now, it's important to note the model still has some room to grow in, production-grade coding and long-horizon agentic systems.
Sure, it's not perfect.
Right, but its dominance in medical and advanced scientific reasoning gave Meta the confidence to make the ultimate operational shift. The model was so highly efficient and reliable enough that Meta migrated all of their daily operational workloads.
The moderation, the bots.
All of it. They moved it completely off Google's Gemini and onto their own highly efficient in-house model.
They fired Google. They achieved compute sovereignty.
Exactly. But if we connect this to the bigger picture, the motivation here isn't just technical pride or, winning benchmark competitions. It is entirely about Wall Street economics.
Okay, the economics.
It's about the preservation of the platform business model. Tech giants are trying to escape what's known as the variable OPEX trap. Operating expenses.
The variable OPEX trap.
Right.
Because if a platform with billions of active users like Meta relies on an external API like Gemini or Claude, every single time a user interacts with the AI, Meta has to pay a variable token tax to a competitor.
Yes.
Imagine paying a fraction of a cent every time someone opens the app. Now multiply that by 3 billion users, doing it 10 times a day.
It adds up incredibly fast.
You are hemorrhaging billions of dollars to a competitor just to keep your own app running. It would absolutely destroy the traditional 80+% gross margins that platform businesses enjoy and rely on.
And that's exactly the nonlinear formula dictating modern ROI. If you rely on operating expenses, you lose. The solution is the financial transformation of converting that expense into CapEx, capital expenditure.
Okay.
By doing the hardware-software co-design we just talked about, meaning you own the physical data centers, the power plants, and you run a hyper-efficient compressed model like MuSpark, you transform that endless variable token tax into an amortized asset. You capitalize the massive upfront investment of building the data center, and you depreciate it over 3 to 5 years.
So what does this all mean for you, the listener? It means once a giant like Meta builds the infrastructure and deploys MuSpark, the cost of serving the next user, the cost of answering your prompt drops to practically the cost of the electricity required to spin the server.
Exactly.
They keep their margins.
They keep their margins, and they don't go bankrupt serving you. And the broader implications of this are staggering, because